volumes of three-dimensional shapes through a cross-section point of view. So let's go ahead and take a look at our stuff. In this lesson, we're going to be defining the volume of solids using a process similar to what we did for the one we used for finding the area under a curve. In that situation, we found the area of the curve by using a limiting sum of the areas of an infinite number of rectangles. If you remember this right here, where we took the limit of the infinite number of rectangle areas, then we got this definite integration. For volumes of solids, we're going to be taking a limiting sum of the volume of an infinite number of thin wedges of varying shaped prisms and cylinders. Okay, so just take the rectangle and go three-dimensional with it. You will get either a prism, or if I have a circular item, then it will be a cylinder. Remember, the volume can be found for prisms and cylinders using this, which is the area of the base times the height. And so the best way to kind of think about it is be like a little slice of bread. Think of the slice of bread. So I have a loaf of bread here, and it's got a bunch of slices in it. And if I take one slice, that would be what we're representing. Okay, it's a little prism. It has a base. Okay, the face would be considered the base. So what is the area of that face shape that is described to us? And then how thick is the slice that we're looking at? So that's what we're going to be looking at here, and that's how we find the volume of a solid. We take a bunch of slices and we find the area of each of those slices of the face, and then times the thickness of it to get a volume of a little cross section. And so taking this all the way out to the extreme here, just like we did for area under the curve, so the volume of each one of those individual little faces or wedges is the area of the face times the thickness. So if I take that to a limit, then I'm going to get the integration between A and B of the area of the face, and that's the thickness right there. And this is the formula we would use for cross sections that are perpendicular to the x-axis. And this is the form we would take if we're going perpendicular to the y-axis. So when we do problems like this, they're going to ask you whether, they'll tell you which way the shape is going, perpendicular to the x-axis or perpendicular to the y-axis. So we have an example here we're going to look at. So let's go through that and show you how that works. So how do we do this process? What should we do? Well, like I said, it's very similar to one we did before. Okay, so we're going to find the volume of the shape with the base bounded by the circle and a cross sections that are squares that are perpendicular to the x-axis. So the first thing you want to do is you want to draw the base in the two-dimensional realm, the xy plane. And that is this circle that they gave you. So you start with that. Okay, and again, it's just a sketch. It doesn't have to be perfect. Okay, and then just like before, here's my x, here's my y. This is x squared plus y squared equals 4. Okay, and we're going to have to draw a little segment that's going to represent the direction of the cross sections. So I'm going to draw a cross sections that are squares perpendicular to the x-axis. Well, I can't draw a square on this because I'm looking at it from the point of view from the top down. So each of those little cross sections would be that right there. And that's why you draw that segment, and then you draw the cross section they described, in this case a square. So off to the side here you draw a square, and what I like to do is I like to highlight this segment that I drew on this shape. So that segment is this part of this square. Okay, because I have to find the area of that face. Okay, and I have to do it in context of it going from here to here. And then the thickness will just be the dx. So how do I do that? Well, this is an area we're looking at, area of this face. This is a square, so we have two side lengths. So the area of a square is s squared. So I have to find s in terms of this length right here. I have to find that distance right there in terms of this. And to do that, I have to break this circle up into equations y equals. So if you solve this for y, you're going to get y equals plus or minus the square root of 4 minus x squared. And that means this top half of the circle is the plus, and the bottom half of the circle is the minus. I'm sorry, 4 minus x squared. So s, in terms of x, is the top minus the bottom, so it is the square root of 4 minus x squared minus the bottom, which is a negative 4 minus x squared. And what I get here is 2 of these, plus plus here, and so this becomes 2 times the square root of 4 minus x squared. That is my side length in terms of x. That is that distance right there. And so since the area is this number squared, so then the area of x is going to be this quantity squared. Okay? And so then what is this number squared? Well, it's going to be 2 squared, which is 4. This square root squared, which is just the stuff inside the square root. And then you can distribute that if you want. And now I know what a of x is. Once I have this right here, then I can go over and I can write this out in an integration format. So the volume then must be the integration, and we're ranging from -2 to 2, because the radius of the circle is 2. I'm going to go from -2 to 2. The area dx, which is -2 to 2, which is 16 minus 4x squared dx. That is the volume, and you must always write that first. Then from that, we can then do the integration and then evaluation of this. So 16x, and then 4x to the third over 3, evaluated from -2 to 2, and then you can work that out. 16 times 2, 2 to the third over 3, minus 16 times -2, 4 times the -2 to the third over 3. And you work all that out and you simplify your answers, and you should get 128 over 3, hopefully. This is the process you're going to follow. Okay? Now, I've written that out for you, so I'm going to show you my notes here, so you can take a pause here and write those out. So be sure to write down the process you're going to follow, and go ahead and pause it here for a few. Okay, so let's take a look at the next page, see if we have another example. So this one is not what I'm going to solve out, it's what I'm going to just show you. Let me get this going here. So in this case, the volume of an object whose base is bounded by the x-axis and this parabola, 4 minus x squared, with the square cross sections perpendicular to the x-axis. So again, square cross sections. And so what do we do first? Well, I have to draw the shape of the base. Let's pull this off here. So here's the parabola in the xy plane. I draw this segment that is perpendicular to the x-axis. This is the cross section, again looking from top down. So these things here have squares coming out of the page, and it's going to get taller because the longer this is, the taller it is. So it's going to get taller and then back down smaller again. And this segment is this segment here on the square. Once I have this drawn, I have to find s in terms of x based off of this shape right here, which is the top minus the bottom, which is 0. And then I can go through that process. So here it is again. A is s squared. Always write the formula of what you're going to plug into so you know what you need to look for. Here is s, the top minus the bottom. So s is just this quantity right here. A takes that quantity and squares it. And then we take this amount and we plug it into our formula over here. and we're going from -2 to 2 on the x-axis. And you can use do this by hand. I would multiply it all out and then integrate each piece and then evaluate, and you get this number here. Or you can also just use the calculator to get this answer here. Okay. On the AP exam, they like you to set things up. Okay. Usually it's like maybe set it up and then use the calculator to evaluate, because they know that if you can set it up, you can evaluate it. Sometimes they'll have you do the evaluation, so you have to be able to do both techniques, calculator and by hand, so be prepared for that. Okay, so let's take a look at another example. This one we'll walk through. So in this case right here, the volume of a solid whose base is bounded by the x-axis, x equals e, and the curve, the natural log of x, with rectangular cross-sections perpendicular to the x-axis. The rectangular cross-sections are 4 times as tall as the given base at any value of x. Okay, so what does this look like? So, same thing as always. We have to sketch the base of our solid in the xy plane. So you draw your sketch. E is right about here. This is E, 2.7. Okay, so here is this line segment. Okay, the x-axis, and we have to draw the natural log of x curve. Okay, so here would be 1 and so forth. And so we know the natural log comes down from here, goes across, and it should hit right here at this point, which we need to find. So what would be that point? This is y equals the natural log of x. This is x equals e. This is my region right here. This is going to be my cross-section wedge. So we need that point name right here. And it's pretty obvious. If I plug in e into here, I'm going to get 1. So this is e comma 1. Okay? Now, this is the bottom part of a rectangle coming out of the page. And it is 4 times taller than it is wide. So if this segment right here is W, then this is what's in the base, this is that. This has to be 4W. Since the area of a rectangle is the base times the height, in our formula here, A is going to be W times 4W, which is 4W squared. So that's going to be the area of this face right there. But I need W now in terms of x. So what is W of x? It is the top minus the bottom. So the top is the natural log. The bottom is 0. So it's going to be the natural log of x minus 0, or just the natural log of x. Which means my area of this wedge in terms of x is going to be 4 times the natural log of x quantity squared. And so we take that, we put it into our formula. My area is 4 times the natural log of x quantity squared dx, and my limits are going from 1 to e. And again, this is a problem if we don't have a rule for, we got to do by calculator. So we can type this into our calculator and you'll get 2.873-ish. And that is our approximation rounded to 3 decimal places. All right, so there's another example there. So let's take a look at yet another one. In this scenario, right here, a solid has cross sections that are squares perpendicular to the y-axis. The base of the solid is bounded by the x and y axes. X equals 1, and the curve x to the third plus 1. So this is my region. Okay? We need to find that point right there. which is pretty easy to do because if x is 1, then y is 2, so this is the point 1, 2. Okay? And so then it said what? It said its cross sections are perpendicular to the y-axis. So that means I have to draw a segment this way. And coming out of here are squares. So I need to draw a square. And this part right here is the base that I'm seeing right there. And so my area that I'm going to follow is s squared. And so I need to find s in terms of something over here. So because we are going perpendicular to the y-axis, I have to change this over so that I have to use a dy, which means I have to solve and get this as, I got to find s of y. Well, my equations though, this equation right here is in terms of x. So I need to solve this for for x in terms of y. So that means y equals x to the third plus 1 has to change, and solving this for x, I'm going to get the cube root of y minus 1. I have to use this quantity, this value right here for x. Okay? Another thing I'll notice here when I do this is and you should always check this out, if I take this cross section and keep running it across, you will notice that it's right minus left. But as I move up, this one is a different right and left than this one, which means this integration is going to split. It's going to split right here at 1. Below 1, this is the right, this is the left. Above 1, this is the right, and this is the left. So I have to write it in two different ways. Okay? So I have to find s of y in both scenarios. There's the top piece and the bottom piece. Okay? So let's look at the bottom piece. In the bottom piece, you will notice that it's just a square, a 1 by 1 square, which makes it a little bit easier. But we can go through the process here. So s of y is going to be the right value, which is 1, minus the left value, which is 0. 1 minus 0, which is 1. And so my area, in terms of y, is going to be s squared, 1 squared, which is also 1. This kind of confirms what we already knew, that this is just a square of length 1. But what about the top piece? In the top piece, s of y, the right minus the left, this is now the left, it's going to be 1 minus the cube root of y minus 1. That is s. And so my area then of that cross-sectional face coming out is going to be 1 minus the cube root of y minus 1 squared. Okay? So we need to plug these things in, okay, into our formula now. So our volume is going to be, and we're going to go from where to where? In this one, we're going to go from the y values from 0 to 1. We're going to integrate from 0 to 1 the area of the bottom piece, dy, and then we're going to add it to here to here, and the y values, so those are going to go from 1 to 2, and we're going to integrate this piece, squared dy. Okay? Let me get my calculator and I'll walk you through this one. Okay, so we can try and work this out by hand, but it's just easier to type it in the calculator. So let's go ahead and do this. Let me put it over here so we can kind of get the glare out of the way. All right, so we're going to menu, calculus. We're going to integrate. We're going to go from 0 to 1, And you don't need to put dy's. You can still put an x in here. It'll still solve it out for you. It doesn't matter to them. They won't know. So we're going to put a 1 here. And we go with dx here. You can put a y. And let's just put a y. Just keep it consistent. And then you're going to put plus. Then we're going to go to menu again. Calculus. Integration. We're going to go from 1 to 2. And this one's going to have a parenthesis. And we're going to do 1 minus the cube root of y minus 1. And then we come and we close the parentheses and we raise it to the second power. And then we put a y here. So make sure all your variables are the same. You should not have anything other than y's in there. And when you do, you can hit Control Enter and you get that answer right there. And this is the best approximation we can get. So this then, my volume is approximately equal to 1.100. Okay? And there you go. So I had a little bit of side note here. I'm going to let you guys take a look at it so you can copy it down, all the little side pieces that I had. Let me move this out of the way. So here's this middle section right here where we have the rectangle. Just talking about how to set it all up. And then down here, the last one down here, again, talking about how we had to split it as we did this problem. All right. So let's take a look at the last example that we have right here. So they can use any shape that they want to describe these things. And so in this case right here, we're going to look for the volume of a solid whose base is bounded by the x and y axis and the parabola 4 minus x squared in the first quadrant, with cross sections perpendicular to the y-axis that are right isosceles triangles, where one leg of the triangle lies in the xy plane. And they describe this like this. They can have the hypotenuse lie in the xy plane. There's so many things they can do to change this problem up, but that's the idea here. Okay, so the process is exactly the same every single time. Draw the xy plane base of your solid. And just, you need a sketch of it. We're going to graph y equals 4 minus x squared. So it's just a parabola that starts at 4 and drops down here to 2. So this is going to be 4 up here. This will be a 2 right there. And this is my area, or the base of my shape in the first quadrant. I want a cross section that is perpendicular to the y-axis. Okay. Now those this cross section, this face, is a right isosceles triangle, which basically means it is half of a square. It's a 45, 45, 90. That means this side is in and this side is in right here. This is what a right isosceles triangle looks like. And this leg is the leg that's represented by that segment right there. Okay? Because I am perpendicular to the y-axis, this equation has to be changed into x equals. So solving this for x, I get x equals the square root of 4 minus y. I need that value for this problem. The area of a triangle is 1/2 the base times the height. In this case, that is 1/2 n times n, or n squared. And so I need to know what n is in terms of y. So n of y, this length right here, is the right minus the left. And so that would be 4 minus y minus 0, or simply just the square root of 4 minus y. So then my area of my triangle is going to be 1/2, and then this quantity squared, which is simply 1/2 4 minus y. And I can continue to simplify this out if I wanted to by distributing this out. And so then I get a of y equals 2 minus 1/2 y. So that is what a of y is. So my volume is an integration, and we're going from where to where? We're doing y values, and so this rectangle is the lowest one, the wedge we have is down here at 0 for y, all the way up to 4. So we're going from 0 to 4. And it's going to be a of y dy. And then we can do this by hand, or we can do this on the calculator. If we did it by hand, we're going to integrate each individual piece. This is going to be 2y minus 1/2 y squared over 2, evaluated from 0 to 4. So that's 2y minus y squared over 4. 2 times 4, 4 squared over 4, minus 2 times 0, 0 squared over 4. So that's just the 0. This is going to be an 8 minus this over here is a 4. And so our answer is 4. Okay, so that concludes the volume for cross sections. Okay, follow this process every time. Be very diligent in your setup and your showing your work so you don't get confused and don't make mistakes, especially when you're going into the area formulas. Make sure you have it out exactly how you're going to plug it into your formula over here. You don't need to multiply things out unless it's nice to do so. Again, mostly what they're going to ask you to do is they're going to ask you to set things up without evaluating. Sometimes they'll ask you to evaluate, in which case you most likely can probably use a calculator. But not always. Just be aware of that. So that concludes this video, and we'll do more in class.